There is no gainsaying the fact that innovators, discoverers, and inventors have to be incentivized to do their thing. And who is the main person who does this incentivization? Mostly it's going to be the government. Of course, there are private individuals, private charities which can carry the role, but mostly it's the government. So, quite naturally, if you use business terminologies like leverage, such innovators, inventors, and discoverers will skew towards areas they think the government has a lot of interest and stake. And of course, if you look at the economic setup, you're likely to bump on the fact that the government likes health, education, and obviously security. So you find a lot of these innovators, inventors, and discoverers skewing their efforts towards these areas. And of course, in the health field, such innovations are very, very numerous, and they happen almost like in very short span of times. If you have to look at just the medical journals, if you visit hospitals occasionally, you're likely to agree with me that the fact that innovation is alive in hospitals and clinics, in medical schools, is you likely to agree with me that it's a very profound, to a very profound level. So if you have to look, for instance, right now we are talking of AI and generative AI, you find that investors are actually clustering around this area of medicals. Yeah, that is no doubt. So if you go to that, and by the way, AI is just another wave in about maybe two-year interval. We had the 3D printing wave, which apparently has been overtaken by AI, depending on what you normally concentrate on, maybe which books you read or what audiovisual materials you watch, etc. But I believe that AI is now trending. But 2 years ago, 3D printing was actually a thing to talk about. They follow the same path almost. So this generative AI is going a lot of it is going to health care. So probably I'll find some materials which I can post just to give a small glimpse of what's going on in the health field. There is also for us to check out there. So I don't see any reason why no one can check on that, and even more important, to share whatever they find. So let me just go through and see which one I find more appropriate, and then of course maybe other scientific fields will follow.
You first talked to me about it in January. I was really excited to join. It feels like it's the Super Bowl for AI, and I couldn't be more excited to be here and talk about the progress that we're making together.
Absolutely. Medtronic is the global leader in medical devices that has served over 76 million patients across 70 health conditions. You've created the ultimate condition to broaden the impact of AI in healthcare.
You mentioned the 76 million patients. So that's 76 million patients a year. That's about two patients every second. And I'm convinced AI is going to help us move upstream to less sick people, high risk people, and we're going to take that number to go from that, call it 80 million a year to 800 million a year. I think that's the power that we have in front of us.
That's incredible, Jeff. Two patients a second, and your vision is to take that to 20 patients a second? Can you tell us more about how we make this vision possible and the role AI plays in medical devices and the applications in patient care?
I talk to physicians every day, and look, they don't want more data. They want insights. They want insights that can lead to action. And so, for us to do this at scale and speed, to meaningfully impact society, we need AI. It's that simple. But I believe, we've only just scratched the surface of what's possible.
Jeff, you make two really critical points. AI is a technology to deliver insights to clinicians that benefit patients. And I think your other point you made is, we're just at the beginning of this journey. AI, just like human intelligence, is a journey of continuous learning and evolution. So, can you share with us any specific use cases, for example, in early cancer screening or surgery, where AI has already made a significant impact within Medtronic and for the healthcare providers?
Sure, I'm happy to share that we're already seeing a number of benefits of AI in a number of areas. So, one, our GI Genius intelligent endoscopy module is the first computer-aided detection system to use AI to identify polyps during a colonoscopy. So, GI Genius scans every visual frame of the entire procedure in real time and then alerts physicians to the presence of lesions, including small flat polyps that can easily go undetected by the human eye, especially after a long day of doing colonoscopies. These things, physicians can miss these. And we recently published the results of our largest trial to date, demonstrating just how using GI Genius can reduce the miss rate of polyps by up to 50% compared to a human only colonoscopy, and that's just huge.
The potential of AI is essentially limitless. And considering colon cancer, and today we're also announcing Medtronic is designing their GI Genius AI assisted colonoscopy system with NVIDIA Holoscan and IGX to support physicians with real time AI enhanced imaging, shipping at the end of the year. GI Genius has been designed to host a suite of AI algorithms, like the Intelligent Endoscopy Module, the first FDA cleared AI assisted colonoscopy tool. It helps physicians detect polyps that can lead to colorectal cancer. Working with the GI business at Medtronic and partner Cosmo, we are also helping enable third-party developers to train and validate AI models for the GI Genius platform, accelerating important applications to get to market. Another field that is continuously pioneering ways to leverage AI is genomics. Last year was an incredible year. NVIDIA worked across the entire ecosystem to make NVIDIA Parabricks accessible in all public and genomics cloud platforms. New genomics sequencing platform introductions using AI to increase instrument throughput and reduce the cost of sequencing to just hundreds of dollars. And achieving the Guinness World Record time of 5 hours for diagnostic sequencing technique. There are two monumental achievements bringing genomic sequencing closer to becoming the standard of care. And for the first time, the completion of the whole human genome was accomplished by the Telomere to Telomere Consortium, introducing another 200 million genomic bases to the genome. Long read sequencing and the platforms invented by Oxford Nanopore and PacBio are the core to this achievement, along with many more discoveries in transcriptomics and epigenomics